Hi, in this video I will work out a few examples involving confidence intervals using z-values. The first problem states the following. A pizza lover wishes to estimate the average cost of a large pizza in Southern California. The pizza lover samples 35 pizzas and finds that the average cost is $22.50. The population standard deviation is $5.30. Estimate the average cost of all pizzas in the region using a 90% confidence level. So the sample mean, X bar, is 2250. The sample size is 35. The population standard deviation is 5.3. Confidence level 90%. We have to find the z-value. So in table F, we look for 90%. And since we're looking for a z-value because sigma is known, we go all the way down to the bottom of the column where the z-values exist, and we get 1.65. Next, we have to type in all this information into our calculator to compute the limits. And I'll show you how to do that. I like to just type it all directly in my calculator. You could work it out step by step if you want to, but how I would type it in if I were using a TI-84 Plus calculator, I would type 22.5 minus 1.65 times 5.3 divided by the square root of 35. Hit enter. We get the first limit, 21.02. Now we can select the equation and then go back and edit it, change the minus to a plus to get the right endpoint, 23.98. I'm rounding to 2 decimals. There's another way of working this out just using the calculator. It has a built-in function. So to do this, we have to click on Stat. We click on Test, and we want to highlight 7, the Z interval, or you could just click 7. And we have two options here, data or stats. Let's pick stats because we know the summary statistics. We see that sigma is 5.3. The sample mean is 22.5. Sample size is 35. The confidence level, which is written as a decimal, 0.90, and then we calculate. We get 21.02, 23.97. Keep in mind that this value is more precise than our value here because I've rounded. Let's repeat this process for the second problem. It states the following. A herpetologist, that's someone who studies reptiles, wishes to estimate the true length of rattlesnakes in the local desert area. Previous records reveal a population standard deviation of 0.62 feet. She samples 25 rattlesnakes in the area and finds the mean length is 2.8 feet. And then we assume that the distribution is normal for the lengths of rattlesnakes. We want to make our estimate using a confidence level of 99%. X bar is 2.8. That's our sample mean. N is 25. Sigma's 0.62. Confidence level is 99%. We go all the way to the bottom because we're looking at a Z value, 2.58. And now we're ready to calculate. First, let's calculate this in the typical manner. We type 2.8 minus the Z value, 2.58, times 0.62 divided by the square root of 25. Left endpoint 2.48. We just go back, select the formula, change the minus to a plus. To get 3.12. Now, for people that have a TI-84 Plus calculator, they have the other option available to them. They click Stat, select Test, go to option 7. So I'll click on 7. Make sure you're on Stats. Type in your information, sigma 0.62, X bar 2.8, N 25. Confidence level is 99%, so we have to type 0.99. Click on calculate and hit enter, and we get 2.48 to 3.12. So you have a streamlined process if you're using the TI-84 Plus calculator to rapidly. Thanks for watching this video.